When sizing conductors for an electric annealing oven operating in a high ambient temperature such as 125 degrees Fahrenheit and connected to 480 volts, several factors must be considered to ensure safety and compliance with electrical codes. The oven contains a 50 kilowatt electric heating element, and the conductors are copper with type THHN insulation. It's also stated that the termination temperature is unknown and that the furnace is expected to operate continuously for more than 3 hours. The calculation begins with determining the initial current. This is done by dividing the power, which is 50,000 watts, by the voltage, which is 480 volts. 50,000 divided by 480 equals 104.167 amps. Since the load is continuous, meaning it operates for 3 hours or more, the calculated current must be increased by 125%. Therefore, 104.167 amps multiplied by 1.25 equals 130.2 amps. The next step involves selecting the appropriate conductor size. Although the insulation type is THHN, which is rated for 90 degrees Celsius, the conductor size must be selected based on the 75 degrees Celsius column in the relevant National Electrical Code table because the termination temperature is not known and a default of 75 degrees Celsius is used. The ambient temperature affects the ampacity of the conductor. Therefore, temperature correction factors located in Table 310.16 of the National Electrical Code must be applied. The question arises whether to use the correction factor from the 75 degrees Celsius column or the 90 degrees Celsius column. The 75 degrees Celsius column is used because the conductor size was chosen from that column. The purpose of temperature correction factors is to adjust the ampacity of the conductor, accounting for the effects of higher operating temperatures on the conductor insulation. The conductor size is chosen based on the 75 degrees Celsius column. That means the insulation is rated for a maximum operating temperature of 75 degrees Celsius. Consequently, the correction factor from the 75 degrees Celsius column is used to adjust the ampacity, accounting for the higher ambient temperature of 125 degrees Fahrenheit. To find the appropriate temperature correction factor, locate the ambient temperature of 125 degrees Fahrenheit in the table. The corresponding correction factor in the 75 degrees Celsius column is 0.82. The corrected ampacity of the conductor is calculated by multiplying the initial calculated current, which is 130.2 amps, by the correction factor, which is 0.82. Thus, 130.2 amps multiplied by 0.82 equals 106.56 amps. Referring to Table 310.16, find a conductor with an ampacity equal to or greater than 106.56 amps in the 75 degrees Celsius column. A 3/0 American wire gauge conductor has an ampacity of 200 amps in the 75 degrees Celsius column, which is sufficient for this application. Therefore, the appropriate conductor size for this application is 3/0 American wire gauge copper conductor with THHN insulation. In summary, firstly, calculate the initial current by dividing the power by the voltage. Secondly, increase the calculated current by 125% due to the continuous load. Thirdly, select the conductor size from the 75 degrees Celsius column. Fourthly, apply the temperature correction factor from the 75 degrees Celsius column based on the ambient temperature. Fifthly, calculate the corrected ampacity by multiplying the initial calculated current by the correction factor. Sixthly, refer to Table 310.16 to find the conductor with an ampacity equal to or greater than the corrected ampacity in the 75 degrees Celsius column. Finally, select the appropriate conductor size based on the ampacity requirements.